Hi guys, so once again this is Engineer Duman Arabis, and uh, today I will be discussing I will solve an example for uh, chapter 3, no? Equilibrium of concurrent force system. Okay, so let's try to solve this problem. Allow the W to be lifted using the crane BC, which is hinged at B as shown in the figure, neglecting the weight of the crane. Question number 1, determine the force in cable AC. As we can see, no, this is cable AC. Determine the reaction at B. Determine the large load that can be lifted if the maximum force of cable AC is 100 kilonewton. Okay, so as we can see, we have the force system. So we have crane, no, BC, and at point C there is a load of 40 kilonewton, and it is also this crane is also supported by this cable AC, and it is connected at point A and point C. Okay, so it is stated in the problem that the weight of the crane is negligible. Okay, so to solve this problem, we'll first draw the free body diagram. We will draw the free body diagram of member BC. Okay, so as we can see, member BC, there are connections, no, at point B and at point C. At point B, it is a hinge support, no. Okay, and at point C, there's a cable, no, supporting this crane. So to draw the free body diagram, as we can see, okay, as we can see, we have the free body diagram. So since point B is an external connection, so we have reactions, the vertical component of the reaction and the horizontal, RBY and RBX, and because AC is a cable, so meaning automatically the direction of this force, tensile force, is always away from the point of connection. And then we have a force, 40 kilonewton force. So as we can see in the figure, we have 3 unknowns, no, and this is determinate, no, because we have 3 equations of static equilibrium. So meaning we can directly solve these unknowns, unknown forces, by using the equations of static equilibrium. So we will start with solving the tension. Since if we will take moment about point B, so of course RBX and RBY will cancel, no, since the only forces that can create a moment about point B are a 40 kilonewton force and this tension T. Okay, so we'll first determine this angle, no, the angle of this TAC with respect to horizontal, so by using geometry or trigo function, the tangent of this theta. By the way, the yes, tangent of theta, so this height, no, this is tangent of theta, this is theta. Okay, so because this is 45 degrees and this is horizontal, so meaning to say this distance is 45 degrees, so meaning this is 8 meters. Okay, so tangent of theta is equals to 8, opposite, no, this triangle. This is 8. This is 18, right? So tangent of theta is equals to 8 over 18, and we can solve the value of the theta. And then summation of moment about point B. So this one. Okay. So again, for consistency in my subject, we will use clockwise moment as positive. Otherwise, it is negative. So if we will take a look to the forces, 40 kilonewton force can create a clockwise moment. So this is positive. And what is this term? TAC sine theta. So basically, this is the y component, no? Y component of this force. So this one, TACY. Okay. And this is TAC X. Okay. So this is TACY, and for the moment arm of TACY is 8 meters, and it is a clockwise moment, positive. And for TACX, so cosine theta, and the moment arm is also 8, and this is a counterclockwise moment, so negative. Okay, and we can solve the TAC. Okay, so we still have two equations of static equilibrium, the summation of forces y and the summation of forces x. So we will use the summation of forces y to get the value of, or the magnitude of, this force RBY. Okay, so as we can see, RBY is upward force, so positive, and we have 40 kilonewton downward, negative, and the y component of TAC, so that is TAC sine theta. Okay, and this is also negative because this force is directed downward, and we can get the magnitude of RBY. So in the same way, we will use summation of forces x to solve the RBX. To get the total reaction, simply use the Pythagorean theorem, no? And we have this value, magnitude of the reaction at B, RB. Okay, for the third question, determine the largest load that can be lifted if the maximum force of cable is AC is 100 kilonewton. Okay, maximum. We will still use this free body diagram, and at this time TAC is given and the weight is unknown. So this is W. TAC is equals to 100 kilonewton. Okay, so to determine the magnitude of W, or the weight of the maximum weight, so we will again use the summation of moment about point B, and by doing that, so we can get the magnitude of the weight W. Okay, thank you. Thank you and good day.